Hey, what's up guys, I'm back with a new video. I'm going to explain indices. I'm going to show you a few examples. Okay, for the first question, it says find the values of x that make the following equations whole. We have here the first question, 3 to the power of x is equal to 8 to 1. Sorry, 8 to 1. Now, in order to find the value of x here, we must make these two bases on both sides equal. So it will be 3 to the power of x is equal to 3 to the power of something to give you 8 to 1. And that something, when you observe and when you look, you will see it will be 4. So it will be 3 to the power of x is equal to 3 to the power of 4 to give you 8 to 1. Therefore, x is equal to 4. Question solved. Not that hard. Let's move on to the second question. It's basically similar. We have here 2 to the power of x equal to 8. Like we said earlier, the bases must be the same on both sides, the left and the right side. So it will be 2 to the power of x equal to 2 to the power of something to give you 8, and that something is 3. Therefore x is equal to 3. Now for the next question here, a bit more complicated, but very simple. You have here x to the power of minus 2 is equal to 9. This question here, very basic, simple question. You see we have x to the power of minus 2 is equal to 9. Recall in the rule when I stated that, let me write it in this corner here, when I stated that x to the power of minus b is the same thing as 1 over x to the b. But it's the same thing here. We see we have x to the power of minus 2, so it'll be the same thing as 1 over x to the power of 2. Now, we must make the left side identical to the right side in order to find x. Therefore, I'm saying the base x here and the indices minus 2 here must be similar to this expression here in the right. Therefore, I must find a value when raised to the minus 2 power. It will give me x. Let me explain what I'm talking about here. You see I wrote down here 1 over x to the power of 2. Let's say when we know 3 to the power of 2 is equal to 9, right? Same thing, you're equal. So let's write it back here, 3 to the power of 2. Now we want to get it in the fraction form. So you will get 1 over x squared is equal to 1 over 3 to the minus 2. This here, all we did was upturn, and we add the minus sign to the power. General rule here is just the reverse of it. Good. We have this here. Now we see here we have the 2, but not quite. We don't have the minus signs, or we don't have the plus signs. The signs are not the same for the indices. So what we need to do now to make this here a positive 2 is to raise this expression here to the power of minus 1. So we have 1 over x squared is equal to 1 over 3 to the power of minus 2. All of this raised to the power of minus 1. But whatever we do on the denominator, we must do on the numerator. But since 1 to the power of minus 1 is 1, we'll leave it at this 1 here. Let me write it down. 1 to the minus 1. Now this here is identical to 1 over x squared equals to 1 over 3 to the 2. Indices are the same, it looks similar on both sides, therefore x is equal 3. Using the rule where I said A over B to the power of n to the power of n all to the power of m is the same thing as A n m over B n m. We did that just now here. That's how we're able to get our values. Now let's move on to the fourth question. Okay guys, we're going to do the fourth question now. Now this question is not difficult. I'll show you exactly how to solve it. We have 9 times 3 to the power of x minus 1 equals 1 over 27. Since x is in the powers, we should make the bases the same, and then we'll equate and solve. Okay, let's break this 9 up and we'll say 3 to the power of 2, which is the same thing as 9, times 3 to the x minus 1 equals 1 over 27. If you guys recall the rule, when the bases are the same, you just add indices once we multiply. So we'll get 3 to the power of 2 plus x minus 1 equals 1 over 27. This here will give me 3 to the power of x plus 1 equal 1 over 27. Okay, so now let's split this 27 up, or let's make it where the base is equal to 3. So we'll have 3 to the power of x plus 1 is equal to 1 over, let's say 3 to the power of 9, because 3 9s equal 27. Okay, I recall the rule now. Remember when I said, wait, let me get it. Yes, remember when I said when there's a fraction and you're upturning it, you have to change the sign of indices. So let's make this here 3 to the power of minus 9. Since the bases are the same, we will assume that the indices are the same as well. So let's say x plus 1 is equal to minus 9. Therefore, x is equal to, you carry up the 1, x is equal to minus 10. Question solved. Boom, bang, bang. I'm going to see you guys in the next video.